Welcome to this tutorial series on IPFS. In this series, we will be covering basics of IPFS, then running an IPFS node on our local system, playing around with the CLI, looking into the JS implementation of IPFS, which is called Helia, deploying a website on this network, and a bunch of files. So let's get started. IPFS stands for Interplanetary File System. In short, it's a distributed file system where there are multiple peers all around the planet running the IPFS node, and any peer within this network can exchange file with each other. Now, there are two key concepts which come when in this protocol. First is content based addressing and another one is location based addressing. IPFS uses content based addressing. So let's see what these two are. In location based addressing, you already have seen your like normal https, you go to google.com. So what happens behind the scene is your internet service provider will look for the IP address of this google.com, and then you just go to that IP address, fetch the website, and then you see it in your browser. In content based addressing, the retrieval happens differently. Here, instead of this, what you do is you directly ask, okay, the network, this is the file which I need, and just get this to me. I don't know where it is. So how does this work? Here, what we do is we calculate the hash of this particular file. So hash, as you know, is unique to a file. A slight change in this file will change the entire hash. So in case of IPFS, what we do is we take this hash and we go further. Now we add some code. It helps the encoding and decoding in the encoding and decoding process of this particular file. And once we combine these two, it's called a content identifier or a CID. Now in case of IPFS, we use this CID for searching a file or getting a file. So a CID is unique for a particular file. Suppose you have any image, it will generate a unique CID for that image, and if you make a slight change in that image, the CID will change. So if you take example of suppose location based addressing, suppose in case of Google, every month or every day or two you see something new on their front end UI, something has means they keep updating. But in case of IPFS, every change will represent a new CID, so you can keep the history of each and every page of that particular site. Isn't it amazing? Now let's see how this particular protocol works. We know the CID, and okay, let's take initially, suppose there are two peers in the network, A and B, which are connected to each other. Now what peer A and peer B also has is maintains a table which is called a distributed hash table. In this particular table, they keep a record. Okay, this file in this particular CID is with me with A. This particular CID QMB is with B. Similarly, peer B will also maintain a table. So since both of them are connected to each other, peer B knows that peer A has this particular CID and peer B has a note of his CID itself. How did they get this CID? From the file. You just hash the file, add the codex, and you get this CID. Now a new peer wants to join the network. Let's say peer C. Once this peer C joins the network, his hash table will be empty. No file. Now once a peer joins the IPFS network, in order to interact with the network, he has to be connected with some initial set of peers who will grant him access to the entire network. Means those peers are connected to some other peers, and this how peer C can navigate for the content through those peers and get to the real peer. So these initial set of peers are called bootstrap peers, with whom you get connected initially once you newly join the network. So suppose peer C is connected to peer A in the bootstrap side. Now once this connection happens, peer A will provide all of his files which are to peer C. So now peer C will update his hash table. So QMA CID belongs to peer A. Now peer C knows this. So suppose peer C, but peer C wants this file QMB, not QMA. So how will this happen? So once you start looking for a file, first thing that IPFS does is it will check within his own node. Do I have this particular file? Well, in this case, the answer is no. Now he sees that in his table only peer he has only peer QM if he knows about this file, but not QMB one. So now what happens is peer C is connected to peer A. He will directly ask peer A, okay, do you know, do you have this file QMB, or you know someone who has this file? So peer A now looks into his table and he sees, okay, QMB file is with peer B. Now peer A will help facilitating a connection between peer B and peer C, so that peer C can start downloading this particular file. So a connection is established, and in this way the network starts growing. So a new peer is added to this network. Now what are the key benefits of this particular protocol? Firstly, the files are immutable. Since the content is immutable, since it's the hash of that particular file, so a particular CID always represent that file. If the file changes, the CID changes. So even 1,000 years from now, if you look for a particular CID, it will always return you exact same file. That won't change. Second is the system is resilient. Suppose peer C downloaded the file from peer B. So now QMB is also with peer C and QMB is also with peer B. Peer C knows that. Just expand this table a little bit. Okay, and now peer B also, once the file is shared with him, and now both of them are connected. So once peer C will start providing the files which he has to peer B, peer B will also record that QMB is also present with C. So suppose one fine day peer B just drops off from the network, he is out. So what about this particular file QMB? Now it's not accessible from peer B, but it's accessible from peer C. So the system is resilient. If a single peer in the network has the copy of that particular file, it's still accessible to all the other peers which are part of this network. But in the current scenario where we use our Web2 services, if the server is down, everything is down. Like you can't access that file. So IPFS makes the system more resilient. Third is, yeah, the links are permanent. So a CID always represent the hash of the file again. So same CID will, so the link which you use for retrieval, which is like works like this: IPFS, the name of the protocol, just a colon, and you just type any CID QM dot or something. So this particular link will be permanent, or it will always return you the file, same file, and there is no vendor lock-in. Anyone can just enter or exit the network anytime they want. No one is stopping them. So this is it for the first video, the theory part. From the next video we will be running an IPFS node locally and playing around with the CLI. We will be adding the files, seeing how this entire thing works in practical. And thank you for watching. Bye bye.